Dear students, welcome to Let's Solve Physics channel. In this video, we will be solving problems from S.C. Verma's book Concepts of Physics, chapter number 2, which is Physics and Mathematics. Now let's understand the question. The first question is, a vector A makes an angle of 20 degree and vector B makes an angle of 110 degrees with x-axis. The magnitude of these vectors are 3 meter and 4 meter respectively. Find the resultant. So here two vectors are given, okay, vector A and vector B, and also the angle which they are making with x-axis is given. Okay, now we need to find the resultant of these two vectors and also the angle which will be made with x-axis by that resultant vector. Now let's try to solve it. Okay,
Let's start drawing them. Okay, so we have been given two vectors, vector A and vector B. Okay, their magnitude is also given and the angle of which they are making with x-axis is also given. So, and these two vectors are in two dimension. Okay, so I am taking x and y axis. Okay, so this is our first exercise. Okay, so let me draw x and y axis. This is my x-axis, this is my y-axis, and it is given that vector A makes angle of 20 degree with x-axis. So let us call vector A, and let me call origin O, and also vector B makes an angle of 110 degrees. So it must be somewhere here. So let us call it vector B. Okay, and it is given that vector B is making angle of 110 degrees with x-axis. Okay, now we need to find the resultant of these two vectors, vector A and vector B. So it must be somewhere between these two vectors, correct? And it has been also given that the magnitude of vector A is 3 meter and magnitude of vector B is 4 meter. So all this information is already given. So whatever we have drawn here, it is as per given problem. Magnitude of vector OA, okay, this vector is 3 meter. Magnitude of vector OB is 4 meter. This is given. Okay, also angle is also given, so we will consider that later. Okay, now in order to find the resultant, we know that we need to decompose this vector along x-axis and y-axis for both vectors, vector A and vector B. So how can we decompose it? So you must be knowing the formula, vector decomposition formula. Okay, so I will give you a quick recall. Suppose this is a vector, okay, vector A, okay, and this is making an angle theta, okay, and this is my x-axis and this is y-axis. So we can decompose this vector A along x-axis and y-axis. Okay, so this would represent the x component of vector A and this would represent the y component of vector A. Okay, clear? Okay, fine. And how do we find it? So Ax will be defined as, suppose this is a magnitude of vector A, magnitude of vector A, and cos of given angle, x-axis. Okay, so in anti-clockwise direction we consider as positive angle. Okay, so it will be given like this, and similarly y component of this vector would be given as magnitude of vector A and whatever angle it is making with respect to y. Okay, so suppose it is giving it is making an angle of theta here, so it must be 90 minus theta. So this would be cos 90 minus theta, and this is nothing but sine theta, right? Cos 90 minus theta is equal to sine theta. Now let's come to our original problem. So let's decompose this vector A along x-axis. So x component of vector A, x component of vector OA will become magnitude of vector OA, okay, and cos theta, which is angle with x-axis. Now clear? So we can write it as 3 cos 20 degree. Similarly, x component of, so you need to be careful here, like which angle is being made with respect to which axis. So here OB, magnitude of OB is given as 4 and cos 110 degrees. Okay, so our resultant would be, we can add up the x component of OA and x component of OB, because both component, okay, for the x component for this OA would be in this direction, and if we extend this x-axis in negative direction, okay, this will be representing the minus value of this x-axis. Okay, so if we project it here, decompose it on x-axis, so it will be projected like this, and it will be in negative values because x-axis in this quadrant is negative. So whatever the projection of OB will be, it will be having negative values. Okay, so now let's write the x. So both components are along this axis, single axis, x-axis, right? Because we are finding the x component of both vectors, vector OA and vector OB. Now I think it must be clear to you guys. Okay, so now let's compute the x component of resultant. Let me call it as R. Okay, so we can add up, okay, these two things. 3 cos 20 degree plus 4 cos 110 degree, correct? Now we need to find the y component. Similarly, we can find y component. Y component of OA will be magnitude of OA and angle made with respect to y-axis. Okay, so here it is making angle of 20 degree with x-axis. Now we need to find the angle made with y-axis. So this OA is making angle of 70 degrees. Okay, because 20 degrees it is making with x-axis, so it must be, remaining angle must be 70 degree. Okay, and cos 70 degree, this is nothing but 3 cos 70 degree. Similarly, y component of OB will be magnitude of OB cos angle made with y-axis for this would be how much? Because it is already making angle of 110 degrees, and we know that an x and y coordinate, angle between x and y coordinate is 90 degrees, so this must be 20 degrees. So y is making this OB is making 20 degree angle with respect to y-axis, correct? So we would be writing like this. So magnitude of OB is 4 and cos 20 degree. So we can write y component of resultant R. Okay, so y component would be this direction. Similarly, x OA would be also along this direction. So both will be in same direction. Okay, for that matter, y component of OA and y component OB, they both of them would be falling on this y axis. So we can add them up directly. So we can add them like this: 3 cos 70 degree plus 4 cos 20 degree. Okay, now we need to find the value of cos 20 degrees and cos 110 degrees and 70 degree and 20 degree, cos 20 degree. So it is not directly available like cos 30 degree or cos 45 degree. So there are multiple ways you can calculate this value, like value of cos 20 degree. I will tell you one simpler method. Okay, so if you want to find the value of cos 20 degree, first you need to draw a unit circle. Okay, unit circle will contain suppose radius of 1. Okay, and then from its center draw x and y coordinate and draw a line, okay, at angle of 20 degree, and then project this line on x-axis, and whatever value it is there, this would represent the cos theta value. Okay, so in this way you can measure it, but I am using calculator here and calculating this value as of now. So if I put this value, so you can check the, like, cos 20 degree is 0.9396, cos 110 degrees is nothing but 0.3420, and cos 70 degree is equal to 0.3420. Okay, now let us put these values. So if we put this value cos 20 degree here and multiply with 3 and then sum, and then again multiply 4 with cos 110 degrees, so the value which we will be getting here, so this will be 1.45. Okay, and similarly if we put the value of cos 70 degree here and cos 20 degree value here, so we would be getting 4.78, right? So we can write it like our resultant vector as x component. So x component is 1.45. In which direction? X direction. So x direction is represented as I, cap I, or vector I. Okay, and y component, so y component is 4.78, and in z direction. So these are my x and y coordinate, x and y component of resultant vector. Okay, so I think up to this point we are clear. Okay, now we need to find the magnitude of this resultant vector. Okay, So as they are in standard coordinates, this represent x-axis and this represent y-axis, so we can directly find the magnitude as a square root of this value. Okay, so let's square the x component plus let's square the y component, 4.78 square. Okay, so if we square it and if you square it and then sum it, this value would be 24.997. So approximately this can be written as 25, and value for a square root of 25 is 5. Okay, now so we know the magnitude of this resultant vector. Okay, now we need to calculate the angle which will be made by that resultant vector with x-axis. Okay, so it will be somewhere around. Okay, so we need to find the angle this vector resultant vector will be making with x-axis. Okay, so we know that that value is represented as tan theta. Tan theta is nothing but the angle which will be made by resultant vector with x-axis. Okay, so if this angle is theta, so we can represent it as y component upon x component. So we know the y component here 4.78 upon x component is 1.45. Okay, so this value will be 3.296. Okay, so now this is value of tan theta. Okay, and we need to find the angle. So how can we find? We can take the inverse of this value. So 3.296, and if you use calculator, then you can find this value as 73 degree. Okay, so now let's summarize what we did here. So we have been given two vectors, vector A and vector V. Okay, and how much angle they are making with x-axis is also given. So x is vector A is making angle of 20 degree with x-axis, vector B is making angle of 110 degrees with x-axis. Okay, and their magnitude is also given, and we need to find the resultant vector of these two vectors, vector A and vector B. Okay, so what we have done, what approach we have followed, we have decomposed this vector. Okay, so we have find the um, projection of vector OA along x-axis. Okay, so this is x component. X component is nothing but the magnitude of vector OA and the cos of the angle made with x-axis. Okay, so here it is making angle of 20, so we have written 20, and magnitude is given as 3, so it is 20. 3 into 20 cos 20. Okay, fine. Similarly, x component of OB is magnitude of OB into cos of angle made with x-axis. So OB is making an angle of 110 degrees. So we are taking as it is. Okay, so magnitude of OB is 4, so 4 cos 110. So we have calculated the x component of respective vectors, so that we can directly add them up. So let's call our resultant vector as R. So x component of that resultant vector would be nothing but the cos this value 3 cos 20 degree plus 4 cos 110 degree, and if you put this value in this, so this will be 1.45. Similarly, y component of OA will be magnitude of OA and angle made with y axis. Okay, so you need to be careful here. So this angle is made with respect to y axis. Okay, so here our OA is making angle of 70 degree with y axis. Okay, so we are taking it as 70 degree. Okay, and y component of OB, so OB is making angle of 20 degree, so we are taking as 20 degree and putting the magnitude of them. And similarly, we can find the y component of resultant vector by directly adding them up. Okay, so this value would come as 4.78. Okay, now we know the x component and y component, so we can easily represent that resultant vector as sum of x component and y component. Okay, so I is unit vector in direction of x and j is unit vector in direction of y, and I have just put the value here. Okay, so this is my resultant vector. Now to find the magnitude of it, I need to take the square of this value, x component, square of y. Okay, sum them up and take the square root of this value. So this value is coming as 5. Now we need to find the angle made by that resultant vector with x-axis. So we can find it by taking the value y component upon x component. So y component is 4.78, and we are dividing it by x component 1.45. This value is coming at 3.29, and in order to find the angle, we need to take the inverse of this value. So it is coming at 73 degrees. So this is our answer. Thanks, guys.